Hello YouTube, this is Mr. Bakari, and today we are going to convert polar and rectangular coordinates. That is going from polar form of a coordinate, which is r theta, to rectangular form of a coordinate, which is in terms of x and y, and we will go back the other way as well, from rectangular to polar form. Okay, so polar and rectangular coordinates are just two different ways of describing the same location on a plane. So here we have a polar graph on the left, and we have a rectangular graph on the right. If the coordinate systems share the same origin and scale, like the point 2 pi over 3 in polar coordinates and 1 root 3 in rectangular coordinates, they represent the exact same point. And we can see this if we overlay them on top of each other, just like that. So as you can see, we are graphing the same point here. All right. So that is a conversion from r theta in polar form to x and y in rectangular. So that's what we're going to be doing here. Okay, so if you look at the triangle in the bottom left-hand corner, so if we draw a triangle from the origin to a point in the coordinate plane, as you see here in red, the hypotenuse is r, the horizontal side is x, and the vertical side is y. And from the definition of cosine and sine, we get x equals r cosine theta and y equals r sine theta. All right. And from the Pythagorean theorem, we get r squared equals x squared plus y squared. So we'll just take the square root of both sides and we have the distance formula here. Okay, so remember r is just the distance from the origin or the pole. All right, and then when we want to find theta, we're going to use the relationship tangent theta equals y over x. So we will use the inverse function here to find our angle. Okay, so these are our conversion identities we're going to use in converting coordinates and later when we convert equations as well. All right, so let's look at some examples. All right, so here we're going to convert from polar to rectangular. All right, so as you can see up here, I've written the two conversion identities we want to use here because our point is r theta. That's what we're looking at here. And we want x and y. So I'm going to say, per my identity, x equals r, which is 4, times cosine of 3 pi over 4. Okay, and then I'm going to do the same thing for y. Y equals r, which is 4, times sine at 3 pi over 4. Okay, so now I will evaluate these. So cosine at 3 pi over 4 is square root of 2 over 2. And x is negative at 3 pi over 4. Okay, so you got to be careful there because this is in the second quadrant. And then we will multiply that by 4. And then sine at 3 pi over 4 is positive square root of 2 over 2. We'll multiply that by 4. All right, so we multiply these two together and we get our coordinate. So we get negative 2 root 2 and positive 2 root 2. Okay, so I like to check to see, well, if you were to graph this, you would go to 3 pi over 4, which is in quadrant 2, and you would go 4 toward it, right? Towards that angle. And if you look at negative 2 root 2 comma 2 root 2, that would be the second quadrant as well. So I always like to check that before I go on. Okay, and so that is how we convert to rectangular form. So if you want to try this one, I would encourage you to pause the video and go ahead and we'll go over it. Okay, so here we're going to do the same thing. X equals r, which is -3, times cosine at pi over 6, right? And y equals r, -3, times sine at pi over 6. All right, let's go ahead and evaluate these. So cosine at pi over 6 is square root of 3 over 2, and x is positive, and that is in quadrant 1, times -3. And sine at pi over 6 is positive 1/2. All right, so we can multiply these together, and we will get -3 root 3 over 2 and -3 over 2. Again, you can check this out. Pi over 6 in quadrant 1, if you go -3, that would be the opposite direction of pi over 6. That would put us in quadrant 3. And -x and -y would also put us in quadrant 3. So that checks out. And that is how you convert from a polar coordinate to a rectangular coordinate. All right. So now let's look at going the other way. So now we've got a rectangular coordinate, x and y, and we want to put this in polar form. All right, so we're going to use these two identities up here. So to find r from x and y, we're going to simply use the distance formula. So I'm going to take 2, square it, add it to -2 squared, take the square root, and that will give me r. So r equals the square root of 8, which is 2 root 2. And there's r. Okay? And now to find theta, we're going to use inverse tangent and y over x. So we've got -2 over 2. And that just simplifies to, that's supposed to be an arrow. That simplifies to -1 over 1. Okay? Now, we can sketch 4 quadrants here real quick. This can be a help. And as you can see up here, x and y, if you go 2, -2, that's in quadrant 4. So if we sketch a triangle in 4 and we put y, -1, x, 1, you can see that x and y are the same. So that means our reference angle is 45. So we have a 45, 45, 90 there. So that means theta is 7 pi over 4. All right. And so our polar coordinate is r, 2 root 2, and theta is 7 pi over 4. Okay? So if you go to 7 pi over 4 and you go towards that angle 2 root 2, that puts you right here in the fourth quadrant. So that checks out. And there's our conversion. Okay? If you'd like to try the next one, go ahead. Okay, same thing. X, go ahead and square it. We'll add it to y squared, and we'll take the square root. And that will give us r. So here we've got root 3 squared, which is 3, and -3 squared, which is 9. That's going to give us 27. And then over here we've got 9. So 27 and 9 is the square root of 36. And the square root of 36 is just 6. So r is 6. All right, so now we'll find theta. Use inverse tangent, y over x. And we can simplify this. The 3's cancel out. So this is just going to be 1 over -√3. Again, if you would like, if this helps, maybe draw a picture. and we are going left and up. We are in quadrant 2. Okay, so I'm going to draw a triangle in quadrant 2, and y is 1, and x is negative root 3. So here you can see that your reference angle is 30 degrees, and theta is going to be 5 pi over 6. All right. So our polar coordinate is r is 6, theta is 5 pi over 6. All right. Check it out. Quadrant 2, 5 pi over 6. Everything checks out, and there is our conversion. Okay? So these 4 conversion identities we're also going to use in converting polar and rectangular equations, and that's what we will look at in the next video. So I hope to see you there.